Hello students, now let us try to understand the concept of hybridization. Okay, so let us try to understand what is meaning of hybridization and how can we understand the hybridization. Okay student, so that is hybridization means it is the intermixing of it is intermixing of atomic orbital. Okay, so that is what we are going to do. We are going to intermix the atomic orbital. So how we are able to intermix the atomic orbital, student? Suppose what we are taking one s orbital. Okay, we are taking the example sp3 hybridization, and simply I am trying to explain that is hybridization. So if you are taking a sp3 hybridization, to take one s orbital, one s orbital, you are taking one s orbital, and then what you are taking, student, that is 3p orbital, 3p orbital. So what will happen, student? What will happen? So s orbital is what is same, this is the spherical shape, student, right? And p 3p orbital is also having, that is one is the px, okay, and another is having, student, that is py. This is the py, and lastly it is there, student, what are there, student? That is pz orbital. So this is z. So this is px orbital, this is py orbital, and pz orbital, and this is s orbital. So what we are going to do is, student, that is you take these three orbital, you take these three orbit, all the four orbital, and you intermix. Okay, intermix. So if you are intermixing, student, it will give four new orbital. How the four new orbital? Suppose this is the one orbital, okay, and this is another orbital, this is another orbital, and this is other orbital. So these orbitals are what is, student? Hybrid orbital. These orbitals are hybrid orbital. Okay, now what you will be able to do this with this, student? These four hybrid orbital orient themselves in tetrahedral manner. So they will be, the together will be like this, student, they will be the tetrahedralically arranged, right? So if any molecule is there, that is the, here is there 109 degree 28 minute, right? Of the same hybridization, student, this is the tetrahedral structure of, this is the tetrahedral structure of, tetrahedral structure of what? Tetrahedral structure of sp3 hybrid orbital, sp3 hybrid orbitals, right, student? Now let us take the example, student. Okay, let us take the example. So first example is what, student? That is we are taking, that is CH4. Okay, so when you are taking the CH4, student, that is carbon atom is there, that is 4 bond required, 4 bond, because 4 hydrogen is there, that 4 bond will be required, that is 4 unpaired electron, 4 unpaired electron. So 4 unpaired electron. So let us see, student, carbon is there, right? So that is 6. So how can we do, student? 1s2, 2s2, and 2p2. So if we see balance cell, how many unpaired electrons are there, student? If you see, that is only 2 unpaired, but how many require? 4 unpaired, because CH4 is there. So this is the ground state configuration, student. This is the ground state. So what we are going to do, student, we are sending this C6 into the excited state. We are sending into excited state. So what will happen, student, if you are sending in excited state? So that is 1s2 comma 2s1 and comma 2p3, right, student? So that is 2s1 means what, student? 1 electron, and 2p3 means how many electrons, student? It should be like that. This is excited state. So now these orbital are getting intermixed, student. So this orbital, if you are getting, means this is the spherical shape, student, s orbital, this one, and then this is the px orbital, student, then another is there, this one is the py orbital, and lastly it is the pz orbital. So this is x, this is the what, student? Y, and this is the z. So they all are getting intermixed, student, and then they are forming what? 4 new orbital. So 4 new orbital, I am saying, they are the equal shape and equal energy, like this will be there. These 4 new orbital were orienting, how they will orient themselves. So if you are taking the orientation of this, they will form, that is tetrahedral structure. So tetrahedral structure is like this, student. Okay, this is the tetrahedral. Now 4 hydrogen are there, student. So hydrogen, only one atom will hybridize, so this is 1s1. Okay, and 4 hydrogen are there, so again 1s1, and one more hydrogen is there, again 1s1, and that is 1s1. So that is the all is having, student. If you talk about this, all is having, that is s orbital. So this all will be overlapping like this, they will overlap with the different of this. Okay, so what will be their, student, how the structure of CH4 will result. So that is, here is there, so here is hydrogen is resulting one, so they form the sigma bond. So again here is there, one is overlapping, so again it forms sigma bond. Again one is there, so again here is for overlapping, again sigma bond. And finally here is there, student, so again it will form, that is, again it is forming the sigma bond. So this structure, student, this structure what is forming, okay, this is forming, that is tetrahedral structure of CH methane. This is what, student, this is, that is, we can say, that is tetrahedral structure of methane. Tetrahedral structure of methane, tetrahedral structure of CH4 molecule, right? Now, student, what other things we can do if you talk about the other. Okay, so other example, if you are taking the example of example, take H2O. So H2O, if you talk about H2O, so oxygen is central atom. How many, that is bond required, 2 bond. So 2 bond means how many unpaired electron? 2 unpaired electron. 2 unpaired electron. So let us see, student. So oxygen is there, oxygen atomic number 1, 1s2, 2s2, 2p4. So now that is, here is the completely filled, and here is how many are there, student? 1, 2, 3 and 4. So 2 unpaired electron required, 2 already there. So they will go, student, what? SP3 hybridization. So this is going SP3 hybridization, student, SP3 hybridization. So after SP3 hybridization, okay, so what kind of structure it will form, student? This is the here, and one will be downside, another will be here downside, and here will be. So here is the one orbital, here is lone pair, then again lone pair, and 2 orbital, 2 oxygen in H2O, 2 hydrogen are there, student. So here is 1s1 and again 1s1. So here is 1 electron are there, s orbital. So there is, what will this s orbital will be overlapping here, student. So that is, here it will forming the sigma bond, it is also forming the sigma bond, this is also sigma bond. Now, student, lone pair electron do not take part in the bond formation. So with O, here is lone pair electron, here is lone pair, and where is, this is the H, and here is H. So this is the shape, it is something 104.5 degree angle, that is the bent shape of what, student? Bent shape of H2O molecule. H2O molecule. Why bent shape, student? Because of this lone pair electron, they pull this bond to here. So this is having the bent shape of H2O molecule. Suppose we are taking another example, hybridization. If you talk about hybridization is NH3. Hybridization in NH3. So if you talk about NH, if you are taking the NH3 example, student, nitrogen is having how much? Nitrogen is having, that is for 3 bond, nitrogen is there. So 3 bond is there, 3 bond. So how many unpaired electron required? 3 unpaired electron required. 3 unpaired electron required. Okay. So let us do the nitrogen 7. So that is, what is 1s2, 2s2, 2p3. So here is the lone, this is lone pair electron, and here is the bond pair. 3 unpaired electron are there. Unpaired electron are known as bond pair electron. Now what will happen, student? This all 1s and 3p orbital will go sp3 hybridization. This will go sp3 hybridization. So if you are going sp3 hybridization, so what the shape it will form, student? It will be like that. This and this 4 new orbital form. How many? In one orbital there is lone pair electron, and 3 hydrogen atoms are there in NH3. So they all is having, what is SS orbital are there. Okay. So this S orbital will be joining here, overlapping here, and overlapping here. So how the molecule they are forming, student? Nitrogen will be in the center. So here is lone pair electron, and if you talk about here is the overlapping, then again orbital is there, here is overlapping, and finally one more orbital will be there, here is overlapping. So 3 bond they form. This is sigma bond, this is sigma bond, this is also sigma bond. Now if you want to put in the bond line formula, so what will be there, student? That nitrogen is there, here is lone pair electron, and here is the hydrogen atom, here is hydrogen atom, and here is hydrogen atom. So you can check it out, student. So this is structure. What is name structure, student? Trigonal pyramidal structure of NH3. Okay, structure of NH3 molecule. So dear student, to understand this you need to read out the book. Without reading book nothing is going to happen, student. So you read out the book, student. Thank you so much for watching, friends.